This video goes over the final exam practice for chapters 1 through 6. Part 2 is chapters 7 through 12. For number 1, the hardest part is recognizing which angle they're talking about based upon the letters. So ABC is this entire angle, while ABD would be this small piece, and DBC is this piece on the right. If you can get that, what they're really asking is, if this is 15 and the whole thing is 78, what is this? So 78 minus 15 will give you your answer. And that is C, 63 degrees. For number 2, they say find the measure of the supplement of angle R. Well, if two things are supplementary, they add up to 180. So here we know that 2z plus 10 plus something equals 180. So we could write it that way, 2z plus 10 plus something equals 180. And if we want to figure out what that something is, we're going to subtract 2z, and we're going to subtract 10 from both sides. So in other words, 170 minus 2z is equal to the missing angle. That's as far as we can simplify this, and that's actually the correct answer, C. If they ask you for the complement, the steps are the exact same, but you start off with 90 minus, or 2z plus 10 plus something is equal to 90, if you prefer. So for number 3, let's go ahead and draw an angle EFG, and we know that FH bisects it. So that means that this angle, whatever it is going to be congruent to this angle, whatever it is. And in fact, those two parts I just labeled in red are represented by these two algebraic expressions. So to solve for x, we can set these two equal to each other. So the first step is to subtract 8x from both sides. We're also going to add 2 to both sides. We end up with 4 is equal to 12. 4x is equal to 12, rather. So x is equal to 3. And to figure out EFH, we're going to plug that back in up here. And our answer is 34 degrees. Because 12 times 3 is 36, minus 2 is 34. So when we're finding lengths of segments along number lines, there's two things to pay close attention to. One is the scale. And notice that there are 2 marks to get to 1. So our step, as they say, is equal to 0.5. Every mark represents 1/2. If we were trying to count by 1, we would get the wrong answer. The second thing we have to pay close attention to is crossing 0. Because if we're subtracting some number over here minus some number over here, it's going to be different because distance cannot be negative. So point A is at -5 and point B is at -1.5. So I could take -1.5 and subtract -5, which is the same thing as adding 5, and I end up with 3.5, which is the correct answer. I could also count over 1, 2, 3, 4, 5, 6, 7 little marks, and if I take 7 times the step, that gives me 3.5. For number 5, 2 smaller parts of a segment, when you add them together, have to equal the whole. So if I take the 6x plus 12 here in blue, and I add the 33 in red, it's going to equal the 8x in green. So I might combine like terms, move all the x's to the right, and if I divide by 2, I'm going to get 22.5 for what x is. But do they want to know what x is? No, they want to know what CE is. So in fact, I take that 22.5 and I plug it in. So I might plug it in here. 8 times 22.5. And the real answer is D, 180. But see how easy it is to choose what x is equal to instead of your final value? So for number 6, if we use the midpoint formula, we're going to take -6 plus 3 and divide it by 2. And we're going to take 1 plus 7 and divide by 2. So my midpoint is going to be -1.5, comma 4. I guess that's down here as A. Collinear points are points that exist on the same line. The only line that has 3 points is A, C, and D. So the answer is B. So for number 8, if we plug in 5 is bigger than negative 2, that's true. But 5 divided by negative 2 is bigger than 0, that's not. D is the best choice. For number 9, the hypothesis is the if statement. The conclusion is the then statement. So our hypothesis is it is sunny. And the conclusion is it is warm. D. For number 10, if you pass the final exam with an 80% or higher, then you automatically pass that class. If you automatically pass that class, then you don't go to summer school for that class. So this is the original statement, and the final statement is then you don't go to summer school. Tina meets the original if, so she meets the final conclusion, that Tina did not go to summer school for geometry. For number 11, if we're subtracting from the same side of this equal sign, that is called the subtraction property of equality. Then if we divide by 2, that's called the division property. So here we have the subtraction POE, and down here the division POE. D is the best choice. Number 12, if we're writing a justification for each step, this is from a definition, from the angle addition postulate. And if we notice the difference between 10x and x, we divided by 10. So this one is the division property of equality. The best answer was A. So the definition of the reflexive property of congruence is that something is equal to itself. Here we have segment AB congruent to itself. For number 14, the definition of the segment addition postulate meets this criteria. And the next one, we're going to do a series of substitutions. We had BD. We replace that with what is equal to AC. And we replace that with what is equal to AB plus BC. So this one was substitution. A. So 15, for two lines to be parallel, they have to be on the same plane and share the same slope. So here we see AG and DH, both on this top plane and heading in the same direction. Because these are given as parallel, C is the best choice. For 16, when we have a transversal, like this line here, that crosses two lines, often parallel lines, but not so here, the alternate interior angles are things like 2 and 7, or perhaps 8 and 1. A would have been the best choice. If we wanted to consider some of the other acronyms here, this is still our transversal, and alternate exterior angles are those like 5 and 4, or 6 and 3. They are on opposite sides of the exterior, where the alternate interior did the same thing. Interior here, exterior over here. Corresponding angles match up in the same position. So 5 and 1, 6 and 2, 7 and 3, 8 and 4. There's 4 pairs of corresponding angles. So for 17, because of these parallel marks, we know that 9x minus 6 is equal to 3x plus 18, which means that 6x is equal to 24, or x is equal to 4. If we want to plug that back into here, we get 30 degrees. So these are also going to be congruent to each other, because 6x minus 6 corresponds down here, and notice that it's a vertical angle with 4x plus 8. So if we set these two equal to each other, we can get 2x is equal to 14, or 7 is equal to x, and they want to know RST. So if we plug in a 7, we get 42 minus 6, which is 36 degrees. C. So for 19, we have to use the slope formula, y2 minus y1 over x2 minus x1, a couple of different times here. So 2 minus 7 over 3 minus 4, that's 2 minus the 7 and 3 minus the 4. And the same thing over here with 3 minus 4 and 2 minus the negative 3. Pay close attention to the negatives. So here we're left with negative 5 divided by negative 1, or just 5. And here we get negative 1 divided by 5. So these two slopes are opposite reciprocals, so perpendicular is the best choice. For number 20, we know that two of the side lengths are equivalent, which is the definition of an isosceles triangle. For 21, if one of the acute angles in a right triangle has a measure of 53.3, we can take 90 minus to figure out the other one. Since it's a right triangle, one measure has to be 90. And anytime we know at least two, we can figure out the third. That gives us 36.7. For 22, we'll start with the obvious one, that S and Y have to correspond. So here for B, that's a big no-no. That's why that one's wrong. And extending from there, we can identify that Z and T should correspond, which rules out letter D. And finally, XY should be congruent to RS, which is not the case here. A is our best answer. So given everything labeled in this diagram, we can figure out the angle right here by taking 90 minus 32, which is going to be 58 degrees. And since this is a vertical angle, it's also going to be 58 degrees. D. So to use the side-angle-side postulate, well, these two share a side, that's AH, and we're told that AM and AT are congruent. So what we need is the angle between them. So that would be angle HAM, for example, and HAT, ham and hat. For 25, we see a single and then a double hash mark, so that represents two sides being equivalent. And we're also told that they are right triangles. So side-side angle doesn't typically work, but it does for right triangles, and we call that hypotenuse leg, HL. So it's either going to be B or D. We just need to figure out the order. So if we go from X to Y to Z, notice that second arrow crosses the single hash mark. So if I try E to D to F, notice it's an entirely different pattern because I start off with, instead of this short little side, the much longer side. That's why I want EFD instead, D. For 26, we're looking at a shared side, so we have side-angle-side. So that means that the triangles are congruent. Therefore, 4x plus 8 is equal to 6x minus 6, and 2x is equal to 14, and x is equal to 7. B. So for 27, if this side is equal to that side, and x is kind of like my midpoint here, then I know that this side is also going to be 3. So AC is going to have to be equal to 3 plus 3, or 6. So that rules out A and C. And then BC is this distance here, which, given a perpendicular bisector, any point on the perpendicular bisector is equidistant. So this one is also going to be 10. D. So YW here is a bisector, and since we're going from the angle bisector to a perpendicular line from these opposing sides, those distances are going to be the same. B, 7. For this triangle ABC, if my side length AB is 10, the mid-segment is going to be exactly half of that, or 5. For 30, we first have to figure out the missing angle. 70 and 50, if we add those together, gives us 120, so there's 60 degrees left. And then across from 50, across from 60, across from 70. AB, BC, AC. D is the best answer. For 31, there's the triangle inequality theorem that says that if you add together any two sides, it has to be bigger than the third side. And this is not true. 1 plus 2 is not bigger than 3. It's equal to 3. So this triangle cannot exist. It would basically be a flat line where here's a distance of 2, here's a distance of 1. How is it possible to have a distance of 3? If you tried, you would end up with a triangle like this. 2, 1, and 3, and it never meets. For 32, we're comparing WXY to yxz, so these two angles here. We see across from this one is 9, and across from that one is 7. Since 9 is bigger than 7, then the measure of angle wxy is also going to be bigger than the measure of angle yxz. That's D. To figure out 33, we can take the Pythagorean Theorem. So 3 squared plus 9 squared, and take the square root of all of that. So the square root of 81 plus 9 is the square root of 90. And this we can simplify because this is 3 times 10, or excuse me, 9 times 10. And when you pull out the square root of 9, you get a 3. That's why the answer is 3 root 10. 34 is indeed a polygon. It's a hexagon because it has 6 sides. Polygons have closed lines and straight lines. For 35, we're going to take 60 minus 2, or n minus 2, times 180, and we're going to divide by the number of sides, and this will give us D, 174. For 36, they tell us that MNOP is a parallelogram. One property of parallelograms is that opposite sides are congruent. So we set these two equal to each other, and this gives us that 2x is 30, or x is 15. They want to find MP, though, so I take that and I plug it in, and I get 75 minus 5, or 70. For 37, TRSU is a rhombus. One property of a rhombus is that all 4 sides are congruent. So I can set 7x plus 6 equal to 4x plus 15. And this gives me 3x is equal to 9, or 3 is equal to x. They want to find SU, which is the same as RT. So I can plug that in right here, and 7 times 3 is 21, plus 6 is 27. For 38, they give us QS, one of the diagonals, and RT, another one of the diagonals. And if this was an isosceles trapezoid, then the diagonals would be congruent. So 14 minus x is equal to 2x plus 5. 3x is equal to 9. 3 is equal to x. B. For 39, we're looking at a rectangular quilt piece, and the dimensions are AB is 20 and AC is 30. So that means the other diagonal is also 30, so we cut it into 2 equal parts, 15 and 15, and BX is going to be 15 inches. This was just a distractor. For 40, if we average the top and bottom bases of this isosceles trapezoid, then we get 10. So notice if we subtract 5 here, then we can subtract 5 again, and our answer is 5. If we wanted to use the formula, we might set it up like this, and get that x minus 15 is equal to 20, and get that x is equal to 5. Or just follow the pattern.